EDM 60204 Measurement and Geometry, Week 12 Designing Academic Tasks. Lesson objectives. At the end of this lesson, you should be able to state the definition of academic tasks in the Google Slides in the comment box. 2. Provide examples of academic tasks in the Google Slides in the comment box. And number 3, design academic tasks for different topics in measurement and geometry in Google Spreadsheet. So let's first of all look at academic tasks. What are academic tasks? Okay. And then Okay, so this is number 1. What are academic tasks? Okay, number 2, why give students academic tasks? Number 3, when to give academic tasks? And number 4, where to give academic tasks. Now, let's look at the definition of academic tasks first, which is LO1. Academic task is defined as the measurable product students are required to produce. Measurable product students are required to produce during or after a lesson using resources available to them based on Bloom's taxonomy. Okay, this one is Bloom's revised taxonomy. And students are held accountable. They are held accountable for the completion of the academic tasks they produced. Like this week, you were given the academic task to come up with 3 activities for each assessment. So you need to complete those activities even after class. So what are academic tasks? Okay, they are given to students to complete either at home or in school. It could be either group work or individual work. Now, the focus is on enhancing retention of a lesson learned on that particular day, week, or month. Okay, and students will produce something upon completing the task given. For example, an essay, a miniature house, a diorama. Like in your case, you completed activities. Okay, activities for the 3 assessment. Assessment for learning, assessment of learning, and assessment as learning. Okay, now these academic tests are based on what the students learn and the learning objectives for that lesson, learning objectives or learning outcomes for that particular lesson. So the activities must be based on what the students had learned, number 1, and number 2, the learning outcomes. So in your case, you had learned about tessellation, angles, lines, and also transformation. So you're using what you know, and you design academic tests for your students. Now, academic tests are the requirements for the product students are expected to hand in, such as an expository essay or a test paper. Now, the resources, okay, when we talk about resources available to students while accomplishing work will be such as a model of a finished essay or the one that is supplied by the teacher or by other students. Okay, and the operations that must be used to generate the product, such as memorizing a list of words for a test, classifying examples of a concept for a worksheet exercise, and so on. So this definition of academic test was in the research paper done by Doyle and Carter 2013. Examples of academic tests. This is LO2. So there are 4 categories of academic tests. Okay, there are four. Number one, this one is according to Doyle. Number one, memory test. Now, memory tasks actually recognize or reproduce information. So it is just from the memory. The activities, the tasks given will be like from Bloom's lower order thinking skills. Okay. So just reproduce the information or just recognize the information. Number two, routine or procedural tasks. Use algorithm to solve problem. Use steps to solve problems. Okay, so this is from the word procedure. Procedural task, procedure. That means there will be steps. Okay, there will be steps like, for example, step 1, step 2, step 3. And then you will get to the bottom of uh, the problem. Okay, so for example, in measurement, when you're asked to measure 2 points, so you will need to decide what tool you are going to use according to measurement sense. So what unit will you be using? Okay, according to measurement sense again. So then you will need to write number one. Okay, step one. We need to choose the correct unit, whether you're going to use imperial or metric. Number two, choose the tool for that particular problem. Okay, so if you are going to measure the distance between 2 points, then you will need a ruler, or you can use a measuring tape. Okay, so you choose the tool. And then number three is the unit that you're going to use. Okay, if you are calculating parameter, then it will be in, let's say, centimeter, millimeter, or even meters. But if you're calculating area, then it will be square centimeters. Or if you're calculating volume, then it will be cubic centimeters. So that is procedural test. Now, comprehension test, number three, comprehension test is where you transform, you combine, or you choose the best information. Okay, so this one is regarding something that you have read and you summarize it, you reflect on it. So this is comprehension test. What do you understand from the text? Do not copy wholesale. You need to digest the idea and then you write it using your own words. Use your own words. Very important. Okay, opinion test is where you state a preference. Okay, you state a preference. So that means, let's say you are given a topic about two things and you have to choose one. Now that is opinion test. Okay, so take a look at all the 4 categories. One is memory test, second one is routine or procedural test, then comprehension test, and then the opinion test. Right, examples of academic tests will be essays, group work, journals, reflective journals, oral presentation like what you have done in our Zoom classes, seminars, case studies, field work, participation, okay, practicums or internship, portfolios, written preparation exercises. This one you did during the tutorial, and examinations. Okay, examinations questions. That one I hope is covered or will be covered in a module on assessment. Why give students academic tests? Okay, you need to be very clear why you want to give your students these academic tasks. Okay, you don't simply give them exercises, homework, activities, okay, just for the sake of giving. You need to have a purpose. What's the purpose? For everything in education, you must have a purpose. Why you are asking your students to do that? Why you are choosing or designing that kind of activity? Who will benefit from it? Okay, and remember that you have to look at students' learning styles. There is the visual, okay, auditory and kinesthetic. Know them. Know who your students are. Okay, here are some reasons why we give academic tasks to students. Okay, number one, enhancement. To enhance their knowledge, to enhance what they already know. Okay, that's A. Retention, so that they can remember it for a long, long time, even after they finish high school, primary school, whatever level of institution or education. For revision, okay, because they're going to sit for their exam. Okay, so this is assessment of learning. Extension, maybe this is something new that they learn. So when you give them academic tasks to do to complete, such as mini project or project, then it's an extension of what they already know. Okay, problem solving skills. They need to know how to solve problems in, let's say, in several steps, in 3 steps. How do you solve the problem? Okay, communication skills. You need to communicate with your team member to be able to solve the problem, to be able to complete the academic task. Okay, not that you can sort of like you do it alone and then you don't discuss. Okay, you either discuss with your team member. That is communication skills. Okay, and then technology skills. Why technology skills? Because nowadays everything is technology. Okay, everything is technology, and AI, artificial intelligence, is going to be a big deal soon. Okay, so I hope you become teachers before that. And to get things done faster, you get information faster, and so on and so forth. Okay. Okay, benefits of academic tests, again, to enhance revision familiarity. This is one. Okay, familiarity. So students will be familiar with the task, with how to solve problems. They get the skills and how to communicate with each other and so on and so forth. Okay, connecting one concept to another, yes. This is something that will be beneficial to students when they get to connect one concept that they had learned with the new concept that they learned today, and making meaning of what they learn. Okay, remember Vygotsky? Mm? Okay, so Vygotsky is where students will make meaning of what they learn uh, by talking to themselves in their minds, and then they talk to others, or they talk to others and then they internalize or they make meaning on their own. Okay, so this is how you actually find the volume of a cylinder, for example, or a cone. Okay, so they are making meaning, right? Okay, so we're not going to do this. So when do you give academic tasks to your students? We gave academic tasks during class. For example, group work to complete or solve a problem. Okay, like the one I gave you during the tutorial. So that is during class. Taking work home, or known as homework. Now, the purpose of this is to enhance retention and deeper learning. Okay, and the amount of work to be done by students should be sufficient, not too many that it takes a long time for them to solve it, but just enough so that they can move on to other academic tests, other subjects. Okay. For example, 3 days for written academic tests, like essays, but longer for written assignment or paper. So 1 week, 2 weeks for assignment of assignments or writing paper. More than 3 days if academic test requires interviews. Okay, I think like one of the modules that I taught where students will have to go and interview people online based on topics. Okay, interviews or interrogation. Okay, we don't interrogate people, we just interview them. All right, so find the best best time to give your students the academic test. For every academic task or exercises or activity, we have to allocate time. Okay, just like what I did in tutorial. I gave you 15 minutes, for example, then I check on you, or 30 minutes. Okay, then during this, I will check intermittently. That means in between 30 minutes and so on. And if you need extra time, then I added 10 more minutes, for example. Okay, but you must keep to the time because your next activity will be presentation. So you will need students to present. Okay, even though not all groups, but at least 3 to 4 groups. Okay, where to give the academic tests? All right, if you have written academic tests, okay, I just put there AT, okay, or AT academic test, then give it to the students, your students before the students leave. That means they will do it at home. Okay. At the end of the chapter, this is for self-evaluation. Now, self-evaluation is actually assessment as learning. Okay, assessment as learning. Now, designing academic tasks, factors to take into consideration when designing academic tests are as the follows. Okay, number one, learning objectives or learning outcomes. So you need to look at the learning objectives when you are teaching, especially when you're designing lesson plan. Okay, success criteria. I do hope you do know how to write success criteria. Based on your LO, you write the success criteria. Okay, for example, if your LO states that you need to calculate the volume, okay, of a cube, for example. Okay, this is number one. Let's say the LO or learning outcome or lesson outcome or learning objective states students at the end of this lesson, students should be able to calculate the volume of a cube. Okay, so what will be the success criteria? Success criteria, okay, as C, success criteria, for example, number one, begin with I can. Now, this is to put yourself in the shoes of your students. So, imagine you are your student, and then what is it that uh, will help you to be able to calculate the volume of a cube? Okay, so you can say, I can find the, let's say, length, width, and height of a cube. Because you need to have that. You need to be able to find the measurements, okay, for the length, the width, and the height, or the base and the height, okay, of the cube. And then number two, I can calculate the volume using the formula Okay, length times width times height. Okay, number 3, I can find the, or I can write, okay, write the correct unit. Okay, IE means that is cubic centimeter. So there are 3 success criteria that the students will need to achieve before they can achieve LO1. So that means when you are designing your activity or your academic task, please look at the LO and also look at the success criteria. Okay, so if you have 3 success criteria, so make sure that when you design according to the success criteria. So first, maybe the activity is to have a few cubes, okay, in a handout, and then you just ask them to identify the length, the width, and the height of each cube. It could be small cube, a medium-sized cube, or a very large cube. Okay, so once they are able to identify that, then next, the next activity will be um, using the formula. Okay, using the formula. So what formula will you be using to calculate the volume of a cube? Right, it is width times length times height, for example, or base. Okay, base 1 times base 2 times height. I prefer to use the term base instead of length, width, and height. All right, so then once they understood that, okay, so you can actually just ask them to write the formula for the 3 cubes. So they will see that even though regardless of the size of the cube, the formula stays the same. Okay, then I can write the correct unit. So this is when they will calculate and use the correct unit. So the focus is in the correct units. Okay, so can you see step by step here when you are creating or designing your lesson uh, activity, especially activity, based on the success criteria and the LO. Okay, so please make sure that you can do this when designing lessons. All right, resources. Okay, so resources, they are readily available, or you need to purchase them sometimes, or students need to bring them sometimes. Okay, or whether they are expensive or cheap or made from recycled materials and environmentally friendly or eco-friendly. So the resources actually is up to your creativity. Okay, it's up to your creativity. For me, I use all cardboards, okay, to make them into shapes, okay, either 3D shapes or 2D shapes, and then create a short video, which I will show you uh, on how to calculate, let's say, area. Okay, so different size, different shapes, and how to calculate the area for different shapes. Okay, so these are resources. Now you can cut out cardboard. You know, the old boxes that you don't use, cut that out, and then bring it to school. Okay, and then you can give it, I mean, like for each table, there will be some shapes, and then they need to use their ruler to measure and then, calculate the area. That is one way and a very cheap resources. Okay, so you don't have to go and purchase some. Okay, next is the end product. So the end product could be a physical product, or it could be a digital product, or it could be a written product. Okay, so far, no teachers have asked their students to create an animation using PowerPoint slides or using Keynote. I have not seen any. So you can be the first, where you ask your students to uh, create a cube, okay, in PowerPoint slides, and then make it rotate, for example, or in Keynote and make it rotate. Okay, so yeah, so that is the end product. Now, if you ask them to write an essay, for example, then that is an end product. Like yours, during the tutorial, it is a digital product. Your end product is a digital product because it is in the form of Google Slides. Okay, so that is an example of the end product. A rubric to assess the academic test. So you do need rubric if it is assessment of learning, okay, because you will be giving the marks. So you do need to have a rubric so that your marking is standardized throughout, okay. But if it is just a activity, then you have the correct answers with you. That is already a rubric. Unless the presentation is graded, unless the end product is graded, then you do have to have a rubric. Okay, so designing an academic test, learning objectives or learning outcomes. Okay, so that means for learning objectives or learning outcomes, all academic tasks must be based on LO. You can't just simply create or design academic tests without knowing what's the purpose of it. So the purpose is here. This is the purpose or the why. Okay, so the LO is the heart of any lesson plan, and it is the guide to designing the relevant academic tests for your students. Now, what you did during the tutorial is based on topics, okay, not specifically based on LO. Okay, but now you know that your activities must be based on LO or learning objectives or learning outcomes. For success criteria that we have gone through, this is optional for some schools, but it is good to have. Uh, most most Taylor's International schools will need you to write success criteria. Okay, if you are going to teach in Taylor's International schools, if you go to other schools, look at your seniors lesson plan. Ask them if you need to write success criteria. Okay, what is success criteria? As I have mentioned earlier, it is a step-by-step guide for students of what they have to do in order to achieve the LO. So put yourself in the shoes of your students, meaning to say, think as though you are your own student. If your students are 10 years old, go down to their level. Imagine you are now 10 years old. Okay? So what are the things that you need to achieve to be able to achieve the LO? So what are the steps? Okay, so I've shown you an example just now. Resources. When designing academic tests, you need to wisely choose the resources, either recycle materials versus in-store materials, meaning whether your school can afford to buy the ready-made ones or they don't have funding. So you have to come up with your own resources, okay, or using recycled material. Whether it's expensive or cheap, some apps in iPad, if you buy in bulk for school, it will be cheaper, okay, versus if you buy individually, and so on. Okay, handmade or store-bought. Handmade means you design yourself using the cardboard from boxes, from shoe boxes. Okay, so you design that yourselves. So those are handmade versus the store-bought. Store-bought will be will be much more nicer, of course. Okay. So yeah. So you need to decide how to do this. Haggard looking or professional looking. Okay, haggard looking means what you made is not so nice. The color is off, for example, and so on. Professional looking means those you can buy from companies, from other company, educational companies. But of course, it will be expensive. Okay. The apps that you have, that I have in my iPad, they're not that expensive. So your school can actually purchase for all the iPads that the students are using, depending on your school budget. Okay, the next one is the end product. Okay, end product, physical or digital or written. So the end product is what your academic task would look like. Okay, so when I ask you to design activities, so you come up with your own design. For example, Joyce, uh, the way she presented the academic task for the three assessment is very clear. Okay, and also she chose some form of design which looks nice and presentable. So yeah, the end product of your academic test, whatever you ask your students to do, will depend on their creativity. But that is what your the academic task that you give your students should look like. Okay, if it is a project, then should have a physical prototype, okay, made by the students. For example, hoverboard. Okay, if you have watched the movie Back to the Future, okay, Back to the Future, um, the hero actually steps on a board like that, okay, and it hovers. It hovers, that means it is off the ground. This is the ground. Let's say the green one here is the ground. Okay, this is the grass. So this hoverboard actually flies. So there will be a distance between the hoverboard and the ground. So this is air. So it is on the ground. Sorry, it is in the air. Okay. So this is a physical prototype. So there was a school. There was a school where they tried making a hoverboard, and it was really fun looking at them. Okay, next one is if it is a drama, then there should be a drama presentation. There should be a script, okay, and then the presentation. Okay, if it is an app, nowadays students from schools, they can create apps, whether it is for Android or for iOS. They can create apps like an app where they can fly a drone, where an app where they can make a robot walk, a little tiny robot walk. It doesn't matter how it looks like. Okay. It can also make an app where you can turn on the lights in your toilet automatically. Okay, by let's say voice recognition, face recognition. So these are all technology. So if your academic task is an app, then it should be a working app. For example, an app to fly a drone, etc. Okay, rubric. We are talking about rubric to assess the academic test. So you can find free rubrics on the internet, or you can make it from scratch, depending on your academic test. If you can find some or one, then you can change a few things in that particular rubric. Free rubric, okay? You can use pre-existing rubric from senior teachers if they allow you to borrow from theirs. And free rubric on the internet is a shortcut to assess your students' academic test, but you need to change a bit here and there to suit your academic test. For example, if it's a role play or drama, okay, or drama, then you might want to change a bit here and there, okay? Also, involve your students in the making of the rubric. So if it's not fixed, if the rubric is not fixed, then ask your students to come up with the rubric, and then you and your students can decide which one is a better version. But if it is fixed, like what we have in Taylor's Uni, then for lectures we just use what we have. Okay, they will feel that they own the rubric and they will work harder towards achieving. Okay, so here are some references for you to go through. Right, here are references.
This is a parallelogram, and a parallelogram is defined as a 2D shape that has two parallel lines, this and this, and they do not have right angles. And their formula to calculate area is actually A equals to BH. B is base, H is height. And there is another 2D shape that has the same formula to find area. Can you think of one? That's right. It's a rectangle. Okay, so how is that possible? So we actually draw a dotted line here, and we're going to cut along this side. Okay, now can you recall or can you remember what other 2D shapes that has the same formula to find area? Correct. Good job. It is a rectangle. Okay, so we're going to cut this along the dotted lines. Now let's see what happens. Okay, so I have this part, this half, and now what I'm going to do is to put it here. So now what do we see? It is a rectangle. Okay, now we know why the area can be found base times height, because this parallelogram, the original parallelogram, looks like this. But when you cut along this side and you put it at the end here, it becomes a rectangle. Now let's calculate the area for this parallelogram. What we need will be a ruler, and this is a centimeter ruler. Now you are very well versed that when you want to start measuring the length of the base and the height for this parallelogram, you must not begin here, but you must begin at the 0. Okay, so that means when you want to measure, it will not be like this, because this is inaccurate. So you have to measure it this way. Okay, so where the 0 touches the end of the side, and then you can measure it here. Okay, right, so this is actually 12.2 centimeter. So the base, which is similar with the top base here, okay, so this is also 12.2 centimeter. So this is also 12.2 centimeters. Okay, what about the height? So the height, we can measure it this way, or you can measure it this way, whichever is convenient. And again, the 0 must be the same line as the top side here. Okay, so let's have a look at this. Okay, so it says here 9.9 centimeter. All right, let's do some calculation. So the area, okay, of a parallelogram, yeah, it's a big word, okay, is base times height. Okay, so the base just now is 12.2 centimeters times 9.90 centimeters. This is 20, and this will give you 120.78 square centimeter. So that's the area of the parallelogram. Now let's see whether when the parallelogram actually changes to a rectangle, is it going to give the same area. So once we take out this end and put it here, so let's measure the height once again. So this is the height. Okay, so the 0 must be on the same line, and you can also see that the reading is 9.9. Next is the base. So this is the base here, and okay, and the reading is also 12.2 cm. Area of a parallelogram is actually base times height. That's all. Bye.